this video, we're going to talk about proportions. So you've definitely heard that word before. I'm not sure if you remember what it is, but it's basically just saying that two ratios are equal. So if you remember from the last video, a ratio is basically just comparing two values. So in this series of cups, let's say green versus blue, we have a ratio of 1 to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So a ratio of 1 to 10. With these gallon jugs over here, the ratio of green to blue, it's also 1 to 10. You could phrase that differently. You could say ratio of 1 to 10 or 1 over 10. And actually, this is going to be our use when we set up a proportion. A proportion is saying that two ratios are equal to each other. So in this example, it might seem silly that we say 1 over 10 equals 1 over 10. But that is a true proportion. When both sides are the same, that means the proportion is true. They are equal ratios. You can also say 1 over 10 is the same as 2 over 20, which is the same as 5 over 50. Those ratios are all the same, even though the numbers aren't the same. The comparison between 1 to 10 and 5 to 50 is the same. Now, the big thing that I see people making mistakes with is they think that the difference needs to be the same. If this is adding 9, this might also need to add 9, but that's not really the relationship there. It's a multiplication relationship. We're multiplying by 10. 1 times 10 gives us 10. 5 times 10, times 10 gives us 50. So the relationship is multiplicative. It's not a addition or subtraction relationship. And that is perfectly expressed basically in this volume comparison. So even though these are cups on the left side and these are gallon jugs, the ratio of ounces, let's say if we actually talk about these as ounces, there's 8 ounces in a cup. So there's 8 green ounces here versus 80 blue ounces. There's 128 ounces in a gallon, so there's 128 ounces here versus 1,280 ounces here. Those ratios are all the same. 1 to 10, 1 to 10, 8 to 80, 128 to 1,280. The ratio remains the same. So the way we could solve for a missing part in a proportion is by using cross multiplication, which it's really solving an equation. I would have preferred if we actually solved simple equations before we jumped into this, but you should have seen this process before. Oops, that's not what I wanted. All right, so using cross multiplication, we're basically going to think about this as an x. We're going to multiply these two together and these two together. X times 10 equals 4 times 5. That's the cross multiplication. We're multiplying these two together and we're multiplying these two together. And now we're going to solve that equation on the left side. I just want to simplify this a little bit. I'm actually going to rearrange this. We prefer to see the number in front, so I'll call that 10x. And 4 times 5 is 20. Now, if you remember how to solve an equation from last year, you want to think about the inverse operation. To get this x completely by itself, we want to think about the opposite operation that's happening here. Well, this is 10 times that x. We want to get rid of this 10 so that it ends up as x by itself equals some number. To cancel out that multiplication, we would divide by 10. So x would equal 2. We divide this side by 10, that cancels out. We divide this side by 10 also. 20 divided by 10 gives us 2. So x equals 2. You could probably even see it in this step. 10 times some number equals 20. Well, that number has to be 2. Remember, you can always check these by just plugging this back in. 2 over 4, I'm taking that value and putting it in place of x. 2 over 4 is the same as 5 over 10. And that's true, those are both 1/2. If I think about that as a decimal, that's 0.5. If I think about this as a decimal, that is also 0.5. So you can always check to make sure that these actually make sense, that your answer actually makes sense. I'm going to do that 2 more times. I'm going to cross multiply 2.4 times 20, that is 48. and 10 times x, that is 10x. And it's the exact same step as what I showed over there. I'm going to divide by 10 and divide by 10. So x equals, x is completely by itself on that side. And 48 divided by 10 is 4.8. I'm going to flip it around, but it means the same thing. 4.8 equals x, and x equals 4.8. Those are identical. One more example just to make sure that we're clear. 10 times 4 is 40. 8 times x is 8x. And if you put them on the other side, if I said 8 times x first, and then 10 times 4 is 40 on the other side, those are identical equations. Either way, my last step will be to divide away that 8, which gives me that x equals 5. And again, you could just plug that right back in. 10 divided by 5 is 2. 8 divided by 4 is 2. So that is just the process of solving the proportion once you have it. But before you do that, most of the time, these are going to be word problems that you need to break down and understand how to set up the proportion. That's the key thing. So really highlighting keywords, breaking the problem down into simpler parts is the key step, especially highlighting the units in the problem. So in this first question, actually here, I'm just trying to shade the correct proportional setup. I'm not solving anything, I'm just setting it up. And what I really want to think about is the word ratio. What I mean by that is, what am I comparing? What two things are being compared in the word problem? So this first sentence says 3 pipes take 60 minutes to water the football field. How much time will it take to water the field with 6 pipes? So I'm talking about pipes and minutes, the time it takes to water the football field and the number of pipes it takes. So my word ratio is pipes over, I'm going to say minutes. You could also say time. I'd prefer to actually use those units there. 3 pipes, 60 minutes. Those 2 units are going to set up my ratio. It could also be flipped upside down. It could look like this: minutes over pipes. Please don't directly jump to this based on that first sentence. The question will really drive this word ratio. How much time, how many minutes will it take with 6 pipes? That is what I'm looking for, so that's how my proportion needs to be set up. And now I'm going to actually put those into the proportion. So each proportion should be set up as 2 ratios equal to each other. A ratio on this side equals a ratio on that side. So 3 pipes, I'm going to use this one, minutes over pipes. 60 over 3. Those two correspond with each other, 3 pipes and 60 minutes. And for the second sentence, I don't know how much time, so I don't know the number of minutes, that's my x, but I do know the number of pipes, that's 6. This is the word ratio being executed perfectly. That, oops, go away. The pipes are on the bottom. 3 pipes corresponds with 60 minutes. 6 pipes corresponds with some number of minutes that we don't know yet. And we can see that that word ratio, or sorry, that proportion is shown here. The second one, on average, Crystal makes 5 free throw attempts, and misses, she makes, that's important. She's making 5 free throw attempts, and she's missing 3. So in that word ratio, I'm talking about making versus missing. How many successful free throws? So this is actually also talking about how many would she expect to make? Would she expect to make out of a total of 200 free throws? So we really need to think about this question. What is this question talking about? It's asking how many will we make out of a total of 200 free throws, out of a total, or attempts, you could even say, but we're talking about how many we make out of the total number of shots. Well, we make 5 out of, you really want to think about how many attempts we have here. So we're making 5, we're missing 3. That's a total of 8 attempts. We want to know how many will we make, some number that we don't know yet, out of the 200 free throws that we actually take. we make 5 out of 8, how many will we make out of 200? And you can see that that portion is there.